Let's keep going. What is the volume in the cylinder after you add X marbles? Okay, well remember, every marble that we put in increased the water level by 3 milliliters. Take a look again. So 1 marble increased the water level by 3 milliliters. What does that mean? It means the volume of 1 marble is 3 milliliters. Remember that we are starting with 60 milliliters of water. Okay, let's do it. What is the volume in the cylinder after, oops, sorry, not that one, 2C. What is the volume V in the cylinder after you add X number of marbles? Well, the volume started with 60 milliliters. Then, every time we add 1 marble, it increases by 3 more milliliters. So the number of marbles is X, and every time we add 1 marble, it increases by 3 milliliters. This equation helps you find the total volume. Let me explain how it works. When X equals 0, then the volume equals 60. Wait, I will make a table. That's even better. I really like tables. X is the number of marbles. Y is the total volume. I'll even write that as volume. B. Okay, so when there's 0 marbles, our volume is 60 milliliters. When there's 1 marble, our volume goes up to 63. What if we added 10 marbles? Think about that. Then what is the total volume going to be? If X equals 10, then 10 marbles times 3 milliliters per marble plus the 60 milliliters we started with, that would be 60 plus 30 equals 90 milliliters. So now, can you see how this equation works? It answers the question, what is the volume in the cylinder after however many marbles you want? Just substitute in X, the number of marbles, and then you can calculate the volume in the cylinder. Let me keep going. Follow along. Pause this video to make sure that you're writing in your notes and doing it yourself. Don't just wait for me to give you the answers. Keep reading. If you started with an initial water level of 60 milliliters and you wanted to make the water reach the highest mark on the cylinder, how many marbles would you need? Okay, what is the highest mark on the cylinder? Here, it's 100. The highest mark is 100 milliliters. So you'd want to go from 60 to 100 milliliters. That is a change of 40 milliliters. How many marbles would you need to add to get it up to 40 milliliters? Well, you could just count marbles pushing the buttons. But I'm so impatient. That's slow for me. I know that each marble adds 3 more milliliters of volume. So to change the volume by 40 milliliters, I can just divide 40 by 3 milliliters, the volume of each marble. How many times does 3 go into 40? Maybe if I write it this way, it makes more sense. How many times does 3 go into 40? That is how many marbles you need to raise the water level from 60 to 100. Divide those numbers and then put your answer on the line, or you can keep dropping marbles and count them. 2E. Plot and label points that show your measurements from the experiment. Okay, the y-axis is volume in milliliters. We'll just call that V. The x-axis is number of objects or number of marbles. There, I'll label that X. Now plot the points on your graph. Remember, when you started with 0 marbles, the volume was already at 60. So your first point goes X equals 0, volume equals 60 milliliters. Then you added 3 marbles. If you followed the directions, you added 3 marbles. So here, x equals 3, and what was the volume after adding 3 marbles? It was 69 milliliters. There is your next point. If you followed directions, next you added 7 marbles. Well, you know what? I didn't do it. I don't know what that was, but I can calculate really quickly. Uh-oh, my computer stopped. Here we are. 7 times 3 milliliters for each marble means the volume increased by 21 milliliters. We started with 60 milliliters and it increased by 21 milliliters. So after adding 7 marbles, the total volume should be 81 milliliters. I'll go ahead and plot that point. I didn't actually do it, but I know what it should be because I know math, and you do too. This is getting easy, isn't it? So when x equals 7, we had 81 milliliters. I guess right about there. Okay, follow the directions after the graph. It says plot and label a point that shows the depth of the water before you added any objects. We did that. The depth of the water before we added objects is 60 milliliters. That's the volume. Next, the point should fall on a line. Use the line tool to draw this line. Okay, I'm going to use my painting tool, but you should use the line tool. Something like that, almost. Next, compute the slope of the line using several different points on the line to form triangles. Aha! Compute the slope of the line using triangles? Okay, let me show you what that means. If you go from one point to another with a right triangle, you can create these, what they call slope triangles. These triangles give you the rise and the run that is needed to calculate slope. And it doesn't matter where you make your triangles on the line because all of the triangle side lengths are proportional. Let me explain more. The base of this triangle, that gives you the run or the horizontal change, the change in x. And the height of this triangle, that gives you the rise. Also, you can call that the change in y, the vertical change. Let me remind you that the slope of a line equals the change in y, the vertical change, divided by the change in x, the horizontal change. This ratio gives you the slope of a line. So can you find the side lengths of these triangles? You need to remember the coordinate points. This first coordinate point, x equals 0, y equals 60. This next coordinate point was with 3 marbles, so x equals 3. The y value, the volume, was 69. Now, can you find the rise and the run from the lengths of the triangle sides? The change in y for this triangle is from 60 milliliters to 69 milliliters. So that's a change of 9 milliliters. The change in x in this triangle, the horizontal change, is from x equals 0 to x equals 3. That's a change of 3. Now you get the slope of the line. When you reduce this fraction or reduce this ratio, it reduces to 3. That's the slope of the line. You can use any points on this line. Let me show you with the second set of points. I'll change my color. So going from this point to this point. Remember, this point's coordinates are 81 milliliters and 7 marbles. So x equals 7, y equals 81. Now, what are the side lengths of this triangle? This side length is the change in x, and it changes from 3 to 7. So the base of the triangle has a length of 4 units. The height of the triangle is the change in y. It goes from 69 to 81. That is a change of, is it 21 units? No, wait, let me think, 12. It's a change of 12 units. From 69 to 81 is a change of 12 units. Let me prove that to you. 81 minus 69 is a change of 12 units. Okay, now let's calculate the slope. The slope is the change in y divided by the change in x. So use these measurements. Here, change in y was 12 units. Change in x was 4 units. Da-ding! The slope equals 3. We got the same answer as previously. You can use any 2 points on this line to calculate the slope because the side lengths of the triangles are proportional. These triangles are scale copies. So you did it. Compute the slope of the line using several different points on the line to form 2 triangles. Does it matter which points on the line you use to compute the slope? Why or why not? Let me help you with your answer. It doesn't matter which points you use on the line because all of the triangles are scale copies and have I better go to the next line, and have proportional side lengths. I hope your spelling is better than mine. There we go. Let's keep going. I'll give you some more help with this one. Next question. The equation of the line in the experiment has 2 numbers and 2 variables. Okay, well, what is the equation of the line in the experiment? Do you remember right here? The volume equals 60 milliliters plus 3x. I'll write that again. We're going to use that equation again, so I'm going to put it right here. The volume equals 60, which is the milliliters that we started with in the cylinder, plus 3x. That means every marble that you add increases the volume by 3 more milliliters. Okay, answer the question. What physical quantities do the 2 numbers represent? Let me circle the 2 numbers. The numbers are 60 and 3. What physical quantities do those represent? I'll say it again. We started with 60 milliliters of water in the graduated cylinder. So this 60 represents our starting volume. Before any marbles were added, our starting volume. And what does this 3 represent? That represents the increase in volume per marble. 3 represents the increase in volume. I'm just going to write the increase in V. Yeah, that's better. The increase in V, which is volume, per marble. Do you know why that is? Do you remember? Did you get it? Because each marble increases the water height by 3 milliliters. The volume of the marble is 3 milliliters. Okay, next question. What does V represent and what does X represent? Well, I talked about this enough, so I think you can get it, right? The V is the total volume and the X is the number of marbles you dropped in. Write your answer here. Type in your answer. Next question. Oh, this is a whole next problem. Let me stop the video and let you catch up.